Today we're going to be having a look at surface area of prisms. So first of all, let's talk about surface area. Now surface area is the area it would take if you wanted to paint every single side of a particular shape. So you can see here that on this rectangular prism there are 3 faces we can see, but there are also 3 faces we can't see. These faces are behind or in the back. Now the purpose of surface area is to basically calculate the amount of paint you might need, which we often measure in how many square meters it can cover, hence how big an area it can actually cover. And that's going to be the goal of today, is to think about, well, how many faces are there, what sort of faces are there, and then to actually work out the surface area. Alrighty, so let's look at the dimensions of this little shape here. So we've got 10 meters by 6 meters by 2 meters. Now if we were doing volume, it would just be 10 times 6 times 2. But for surface area, it's a little bit different. So surface area, you need to think about all of the different shapes. So the first shape we've got is this top shape, right? And this top shape up here is 2 rectangles. And you go, why is there 2 rectangles? Well, the reason there's 2 rectangles is there's one on the top, but there's also one underneath that looks exactly the same. Similarly, we can tell that this face on the right-hand side also has a partner. It has a partner on the left-hand side that we can't see over here. And similarly, we have this front rectangle that's going to have a partner on the other side on the back here. So how many faces are there in total? Well, in total there are 6 faces, and they're made up of 2 identical rectangles, which is our top and bottom, plus 2 different rectangles. Now these ones are going to be the left/right ones, plus 2 rectangles which are going to be the front and back. So we now have basically a formula that we've just written. How many different things do we have? We've got 6 rectangles, the top and the bottom are the same, the left and the right are the same, and the front and the back are the same. Alrighty, so 2 times, length times width, plus 2 times length times width, plus 2 times length times width. And now we just need to check what are the dimensions of each of these shapes. So for the top one, the top bottom shape, well, the dimensions of that one are 10 and 6. Whereas for the left and right one, the dimensions are 6 by 2. And then for this front one, let me do it in black. For this front one over here, the dimensions are 10 by 2, okay? And I'm just reading it off, basically, because this side's the same length as this side, so these are all having 2 for the height. That's for the red and black one. And for the top one, it's got the 10 and the 6. Alrighty, so now I can start substituting in. So it's going to be 2 times 10 times 6, plus 2 times 6 times 2, plus 2 times 10 times 2, which gives us a total of 120, plus 24, plus 40, 184. Now, because it's area still, it is going to be square meters, okay, not cubic units, because remember, we're actually measuring the area of all of the outside faces. Let's have a look at a triangular prism instead. Now this triangular prism has its base at the front here. This is actually the base. And this is actually the only matching side. The side that it matches with is invisible in one sense because we can't actually see it. It's off here in the distance. So there's the second one. They're matching on opposite corners. Okay? But on top of that, we don't have 6 faces this time. We've only got 5 faces. The 5 faces we have are the 2 triangles that we just spoke about. So surface area is equal to 2 times this triangle plus, and we've got three different rectangles. We've got the rectangle on the slant. We've got, if I draw back in that scaffolding, you've got a rectangle on the bottom, and then you've also got a rectangle on the left. So we're going to have three rectangles as well. So plus rectangle slant plus rectangle bottom plus rectangle on the left. Okay, so those are the three shapes we've got. All right, I don't actually have any dimensions yet, so let's check some dimensions on this triangle. All right, let's say that this is 15 centimeters, 8 centimeters, we'll say something like, 10 centimeters. Alrighty, so let's work out the areas of each of these shapes. So for the two triangles, it's going to be 2 times a half times BH, or half BH, plus length times width, plus length times width, plus length times width. Alrighty, so for the first one, it's going to be 2 times a half times, now the base times height, well, for the triangle, the base is 15 and the height is 10, so it's going to be 15 times 10. The slant one I'm going to leave for a second. We know one of the dimensions is 8. We actually don't know the other dimension just yet, so we'll leave the slant for the moment. The bottom is 15 by 8, and the left side is 10 by 8. Okay, so then the last question is, what is the length of the top rectangle? So let's do this one in blue. Alrighty, so what's the length of it? We know that the width is 8, so it's going to be something times 8. The question is, what is that something? Well, this is a right angle triangle on the front, right? This shape here is a right angle triangle. What does that mean? Well, we can do Pythagoras to it. So let's quickly do some Pythagoras. So we've got c squared is equal to a squared plus b squared. Let's redraw the triangle with just the information we have. So we don't know the length of that side, and we know that that's 10 and that's 15. Problem. Actually, not really a problem. This is going to be the hypotenuse, so that's going to be c, and then this can be a and b. And so you get c squared is equal to 10 squared plus 15 squared. C squared's equal to 325. C is equal to the square root of 325, which is equal to, and we get that the hypotenuse is 18.027, which we round to 0.3, which I'm just going to round to 18 centimeters. Just in this particular case, I'm going to go with to the nearest centimeter. Okay, so 18 centimeters, well, that is now this length here, which means that I can now fill in my bit in the formula, and now in one step in the calculator, I can determine the surface area by just typing all of this in, double checking it, and clicking equals. And the answer we get is 494 square centimeters. Once again, we're doing surface area, surface area, your answer is squared units. Alrighty, so that's 2 examples of surface area of prisms. I'll see you in the next one. Goodbye.